Okay, this is page 67, question 2, part A. We have a parallelogram called ABCD. We're told that DP compared to PB is the ratio 1 to 2. That means from here to here, if this is 1, from P to B, from here to here, is twice as long. That means that this line is separated into 3 pieces, a 1 piece and a 2 piece. Okay, now we have to express in terms of x and y vector AB. 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 Okay, so to get from A to B, we'll go this way, which is the same as this line, 3x. So AB is 3x. Nice easy one mark there. Next question. This was part 1. Part 2. Next question. BD. BD. To get from B to D, we will travel through roads that already have a name. This one was called 3x. So what you could do, let's go through this road from here to here, and then from here to here. So that will be travel from B to A. That's a BA arrow. And then take a AD arrow. Okay. So a BA arrow is a minus 3x. And an AD arrow is a minus 3y. Okay. Next, part 3. We have to work out DP. We want to get this arrow here, DP. So we'll have to take some existing roads to get from D to P. What we know, check out this interesting piece of maths here. We could work out this long line. We could work out that whole long line, and when we get the answer, we divide it by 3 and we'll get dp. So we have a step 1. So this is part 3 here. I'm taking this question and I'm moving it up to here. Part 3. Step 1. We're going to find db in terms of x and y. So db, as the orange line, would be, we could go from D to A, and then we could go A to B. Remember, we choose arrows that already have common letter names. A dA is 3y plus 3x. Okay. Or we could say 3x plus 3y if you want to keep the x first and the y next. Right. Okay. That is going here and then up here. Get a 3x first, then a 3y. Okay then. So if we know dB and we want the question asks us for dp, dp is equal to one third of the dB arrow. It's one third of the 3x plus 3y. And that turns out to be 1/3 times 3x gives you x, and a 1/3 times 3y gives you y. That's your answer for part 3. Now we have a part B here. A part B says show that AP is, we need to show that AP is equal to x minus 2y. This is AP here. X minus 2y. So remember, if you want to find out AP, one of the things you can do is you travel through lines that already have common letter names. And we have a name for this line here, and we have a name for DP already, which we just did. So let's try that. Right? We will say AP. We could travel from A to P by going from A to D first and then taking D to P. So what's AD? AD is minus 3y. And then what is DP? X plus y. Hope you understand that. Let me color code it for you. DP is x plus y. Here is x plus y. Okay. So now we could add like terms. What is y take away 3y? 1 take away 3. Go for elevator ride. 1 and then you go down 3. You'll end up at minus 2. 1y take away 3y's gives you minus 2y's. So this here, let's write it out like this. Let's bring this x right here plus y and take this minus 3y and put it in the back here if you didn't see it. 1y take away 3y's gives you minus 2y's. So you end up with x minus 2y. And so you've just proven that AP is equal to this. Now you're given that E is the midpoint of DC. E is the midpoint of DC. Let's put the E here. Prove that A, P, E are collinear. A, P, and E are collinear. That means they are on the same line, in the same line. They parallel, same direction, and they also line down on top of each other in the same line. So we have to say two things to get the marks for collinear. We have to say that they parallel and they share a common point. Okay. So let's play with this and so what we're going to do is to show that AP and PE are collinear, we're going to find out what is AP in terms of common letters, and we'll find out what is PE in terms of common letters. And that way we can, once we get the common letters, that should be able to have the information to prove that they are parallel and share the same point. So let us try it and see. Okay, step 1. We are going to find out what is AP. We have that already, right? We're going on this part C. We want to show, right? So we are showing that point A, P, and E are collinear, are on the same line. Okay, so step 1. Express AP in terms of common letters. So step 1, AP in terms of common letters from the last part of the last question. Look right here, the last question. We know that AP is x minus 2y. So x minus 2y. We know that from before. So that's step 1. Now we're going to work out what is PE. We know what is AP. Now we're going to work out what's PE. Step 2. Work out PE. So let's look at the diagram. PE, we need to travel through arrows which have letters already. So we can travel down this arrow here from P to D, and then we can travel from D to E. Okay, so PE would be traveling from P to D and then traveling from D to E. Let's try that now. PD. Do we have PD before? PD. Well, we don't have PD, but didn't we do DP? Look at it here. Part 3. We went from D to P. We worked out that DP is x plus y. So if we know DP is x plus y, let's make use of that. Since DP is equal to x plus y, you see you have to remember what you did in the past because you're going to use that past answer to help you out here now. DP is x plus y. D to P is x plus y. So then you need it in reverse. That will be the negative of x plus y. So put it this way. It is dp in reverse. Do you understand that? PD, showing you here, PD is the dp in reverse here, and then we add de. Let's go now. We know dp is x plus y, so we need a minus x plus y. Let me color code that for you there. dp is x plus y. So since we want to go in reverse, it must be x plus y in reverse as the minus dp. Okay. And then what is de? Let's look at the diagram. D to E, an easy midpoint. So if D to C is 3x, then D to E would be half of 3x. Half of 3 is, if you had $3 and you're sharing it in half, wouldn't that be 150? So half of 3 is 1.5. So from D to E must be 1.5x. So D to E is 1.5x. So we could go 1.5x. It would have been the 3x divided by 2. So I should have said it here. 3x divided by 2. That's why I get 1.5x. Good. Time to simplify this. A minus outside the brackets is like a minus 1 outside the brackets. That'll give you a minus x and a minus y plus 1.5x. Let's group our like terms here. I'm going to put this 1.5x up in front. 1.5x. Take away 1x. Remember, this x is like taking away 1x. And then take away 1y. So what's 1.5 take away 1? That's like $1.5 take away $1. You'll end up with just $0.50. Or 1.5 mango take away 1 mango, you leave it half mango. So 1.5 take away 1 is half. We have half x and minus y. Okay, now time to compare. We're going to compare AP and PE. Okay, now if we take PE and multiply it by 2, what we get? Multiply. Let's try multiplying PE by 2. That is this, 2PE. 2PE would be 2 times a half x minus y. What's 2 times a half? 1. And 2 times minus y. And what is x minus 2y? Ta-da! X minus 2y is AP. So what we just showed there is that we could say now, therefore, therefore 2 PEs is equal to 1 AP. So if you take a AP, or if you take 1 PE and you multiply by 2, which is multiples, then you'll get this vector. Okay, so what we have to say here, AP is a multiple of PE. So that means that therefore they are parallel, right? And both vectors have the same point P. This vector PE has the point P on it. This vector AP has the point P on it. If you can't see it, look at it here. AP has the point P on it. PE have the point P on it. So they have the same point, a point that is on both vectors. So we have to say both vectors, these two vectors, both vectors PE and AP have the same point P. P. So now that you're saying they have the same point and they parallel, right? That means they are equal. Then you can say, therefore, all the points A, P, and E, right? Points A, P, and E are collinear. Ramaki J.